Okay, so let's say we've got a surface that's parameterized like this. Z is cosine u, cosine v, y is sine v, x is u squared. V goes from 0 to 2 pi, so your cosine and sine both go through a complete cycle. And x equals u squared, where u can be anything from 0 to v. Now, we'll talk in a minute about what that surface might look like, okay? But there's a good surface and a fairly simple example of how you would go through the process of calculating the surface area. Okay. Now your region is defined in terms of u and v, not x and y. Okay? I mean, x and y are defined in terms of u and v, you know, the parameterization and so forth, but this then is just what? The integral of 2u, which is your tx cross ty, and let's say u is in terms of v, right? So we have to integrate with respect to u and then with respect to v, right? And u goes from 0 to v, and v goes from 0 to 2 pi, and that's an almost trivial integral. You're going to have u squared, so you're going to have 2 pi v squared. And you can work out the details of that in case I screwed it up. But you get u squared here. From 0 to v, u squared gives you v squared, and then you get 2 pi here. Okay, so it's a pretty simple parameterization, and should probably be a pretty simple surface, right? Okay? Now we don't have any idea what the surface is, and usually you start out with the surface and then figure out what the parameterization is. So we're doing a parameterization to see what a surface looks like, and then we'll parameterize a couple of simple surfaces. Okay? But what you should see here is once you have your parameterization, it's easy to do this. That doesn't mean necessarily easy to evaluate your integral, but once you have your parameterization, it's easy to set up your integral.